Welcome to Zip Code, and today we are looking at another cup of code. We are talking all things webhooks, and we'll be seeing how we can implement webhooks in Spring Boot and the microservices architecture. We'll be using reactive webhooks because those offer us the RESTful stateless behavior within our architecture, and it conforms to the high scalability and high performance that we always aiming for within our design. So this year or going forward, I'll be showcasing or showing my face going forward. So this will be the first video where you'll be seeing my face, and I hope that you guys do like and subscribe and stay tuned for more dev tutorials. For now, I can just request that you do like and subscribe, and let's proceed with the tutorial. So yeah, um, we are going to be focusing on Webhook microservice. So a webhook is essentially an HTTP callback, sort of a event-driven design, and that's basically a sort of a unidirectional listener based on a particular event being triggered by the service. So let's say in your architecture, if you have a particular event like notifications and things like that, so a particular event will be triggered like an SMS notification event or a user registration event, and then that particular event will then push a call to your webhook microservice or your webhook in this instance. Then that webhook can then consume that event, and then based on the parameters that we passed to that event, it can then process that payload accordingly and basically persist that, or then propagate the data into another microservice based on the journey of that particular flow. And in a nutshell, that's a web service. So the projects that we'll be looking at are available in our Git repository, so please do check those out. They're available in the links are available in the description down below, so please do check those out. We have the Webhook microservice, and we have the event trigger microservice. So the event trigger microservice, we'll be using it to actually send the event, and then that particular service is responsible for then triggering or sending the data or sending the event to the webhook, and that's the design that we'll be going for. So please do pull the two services and play around with them. Make sure that they are both running at the same time when you run the test, as I will show you now in our Postman. So what we have in the event webhook microservice, we have an employee event, and you can see that I have the HTTP localhost 8080 / event. And in the body of the request, I do have the name of the event, which is add employee. So if I actually send let me just make sure that the project is running. Okay, so let's just do that. Just make sure that both of these are running. Let's run this as Spring microservice, and let me also start this one. Please note they are not dependent on each other, so the only thing is we want to have the event trigger to actually just trigger the event, and then it will propagate into the webhook, and basically we see the process flow of everything. So right now I just want to demo this to you so that you can see what we are trying to achieve. So I'm going to send this request, and this request goes into the event trigger service, and then after hitting that particular service, then the event trigger service will then propagate or make a call to the webhook microservice, which in a nutshell can be async. It doesn't need to await a response. It can just execute that particular or send that particular data through without being concerned about the response coming back. So let's see. Okay, the application is started. Let's send that again, and you will see that we will get our success. Okay, my PC is just slow. Okay, now it's back. So we do have a success here because the event went through successfully and was processed. Um, it was sent to the webhook. So whatever happens in the webhook microservice, that's a different conversation altogether. But in a nutshell, what we want to do is we have an event here of add employee. So employee event is we want to add this particular employee, and we can have different parameters introduced or added into the particular message that we want to send through with the event, and then that payload can basically be sent into the webhook, and then the webhook could basically then handle that particular request. So that is what we'll be looking into now. Let's start on the initializer because that's where we always start. I'm just going to do the webhook microservice configuration, and then the event trigger you can just pull from our Git repository and use that instead. So the project is Maven based, the language is Java as always, and the Spring Boot version is always recommended. Always take the latest stable version of Spring Boot, and also with your libraries, dependencies, every resource you're going to make use of, make sure you get the latest stable versions so that you always have the long-time support for all your dependencies as well. And then the project metadata is com.zipcode. The artifact is Webhook Microservice. And then the description is demo project for Spring Boot, and the package name is the group.artifact name, and basically that's the packaging of of the project, and we package that as a jar, and the Java version is 17, so 17 should suffice. We should be fine with running any with running what we are developing here on our microservice in that respect. So let's move to the dependency side. We have DevTools, and then we have Lombok, and we have Spring Reactive Web, so that we can basically scaffold Reactive Webhook and have our RESTful APIs in our design, because that's what we always aim for. So that has been mentioned, and the repositories have been shared also, as I mentioned earlier. Now let's move into the code base. So you saw the demo with this particular event being submitted. Let's jump into the code. So we're going to open the event trigger microservice. That's where we're going to start. And in the event trigger microservice, what we have is, let's start from the main package, and that's basically just the application.java, and it enables the Feign clients, because we're going to be making use of OpenFei to make our call to the webhook, and you will see how we basically make that particular call to our Feign client. So the only annotation that we added on application, the main class, is just this annotation over here. Then once that is set up, let's just move to our controller, which basically takes the event call, and we have our event controller addressed controller annotation. Then we have our dependency injection here, that is the event handler service, and what we're doing is a constructor dependency injection here of our event handler service bean, and that basically should suffice. We can also change this implementation or this dependency injection into a add auto wired with that particular annotation over there, and this should also suffice for what we're trying to achieve, and that should be fine. And then you will see that we also have our post mapping here, which is event, and if you go to our post mapping, you will see that we only have this call to event, and we have a request body of event that takes in a request body of event TTO, and we have all the annotations for, and these are coming from Lombok. We have a data, a builder, all args, no args, a JSON, ignore properties, and then we basically serialize all the payload for our event DTO, and you'll see we only have one field in our DTO, which is the string name, which is what we have over here, and that should suffice for what you're trying to achieve. So the event name is what we are interested in, and based on the event name, you can process that particular message or that particular payload that came through from the event. So that's the DTO. Then we can go back to our controller, and then here we basically then call the event handler service dot process, and then we pass in the event that we want to process, and we then say based on the response, which is a boolean here, process true or false. You will see that if we manage to process the event successfully, we just return it true. If we process the request with some issues, we'll just return a false. So if I go back to the controller, you will see that if you get a true, then we return a success. If you get a false, then we return a fail. In a nutshell, that's basically what we're trying to achieve over there. Then let's go into the event handler service, which is where our business logic sits. And in the event handler service, we have our annotation here. It's service bean, and then we have our Self4J for some logging, and then we have our dependency injection of our webhook fain client, and we'll go and check how the fain client looks in after this. So we have our webhook fain client, and that fain client we're going to use here in our process method. And then our process method returns a boolean, and then what we do is take in the event DTO, and then that particular event name. If it's equals to add, we just create an employee here, and right now we're hard coding it, but this is just to showcase that after you receive that event, you can do some processing before sending the data through to the webhook or propagating the event into the webhook. So what we do is just create like a dummy employee over here. Once we have that employee, we then make our call to the webhook over here using our fain client, and we create a new employee, and we pass in the payload for that particular event. And once that is done, we then await a 200 OK. If we do get a 200 OK, then we return true, which means this was processed successfully. Otherwise, return a false, which means it failed or something like that. So if I go back to Postman and I, let's say, send a update event, which is not registered yet within our event trigger, you will see we receive a fail because the update event is not catered for, so it is an exception, and therefore we will receive a fail. But if I put it back to an add, which is what we are catering for, it will go through and we get a success back. And if I for some reason, let's say maybe I stop the Webhook microservice, I stop that particular service, and I do a application shutdown requested. Let me see if that stopped. All right, so let's go to the our Postman again, and I send that request. And if I don't receive a success, now you see I receive an internal server error, which means here I just need to add my try catch. Let's just do that quickly. So let's do a try over here, and we'll try that, and then we'll catch any exception that's going to happen here. And let's just log this. Log dot just log the error e dot get message. I just want that, right? So we're gonna log that error over there so that we know what the cause is, and after that we can just return false right here. And now that we've catered for that, we can basically go back to our Postman. Let's wait for the application to bounce. Okay, so our event trigger is back. Now, if we go there, remember the Webhook microservice has been stopped. So we send this event, and for whatever reason, maybe that service is down. Now we know that the event has failed, and because the event has failed, what we can do then, because this is a microservice architecture, we want to make sure that we keep the log of all the events that came through, so that when the service is back up, we can then replay these events, and then the webhook can be called again to basically process all of these events that are now have been requested, but they were not processed successfully. And this is where you manage the status of your events, whether they ran through successfully or they were due for a retry process. So you can put in place your retry mechanisms in these type of scenarios. And it's a good thing that we're testing this microservice in real time, and you can basically see the errors that we can basically come across and resolve on the fly. So if I had like a database connection here, I would then have um, an events log table that will take all my events and the status of all those events. And for the failed events, I need to log the messages: what failed, what happened, where, and if I can retry those messages, I can just retry those particular messages, and then they can be resent to the webhook and processed accordingly. So now let's bring back the webhook microservice. Let's go back there. Why is it not doing what I want? Let's see, right? So run this as a Spring Boot application. So that application is going to come up right now. Once this microservice is back, we can then just run that message and you will get a success. Let's just wait for it to come up. Should be done in about now. Right, so that's done. Now if I resend the add event, you will see now we get a success because the service is back up. So for whatever reason, if there's any issues with the Webhook microservice, then you can basically catch those exceptions, log the failures, and retry them later on and when your service is back up. And this is a fail-safe mechanism, and this is what we're talking about when we talk about event-driven designs or the event-driven approach within the microservices architecture. And then now the one thing that is left in the event trigger is checking our Feign client. You saw that the Webhook Feign client, we have a create new employee, and if we go to our Feign, Webhook Feign client, as you can see here, it has the annotation at Feign client. The name is the Webhook. The URL is the base URL that is pointing to the Webhook microservice, which is localhost 8090 API, and then we have the call, which is the post mapping that we have here, which is the value is employee, and if you go to the Webhook microservice, let's open the Java package, and we will see in the controller we have employee controller, and we have our request mapping of API, and we have all these employee endpoints, just like we'll go to these just now. So let's just finish this side, and you will see once we move over to the Webhook microservice. So this API Webhook is the call that we make. It's a post call that we make to our Webhook, and then we basically just tell it the media type that we want to consume and the media type that is produced, which is application JSON. And essentially what we do is just create the employee with the request body of employee DTO, and the response entity, it expects a string to come back, and if we do have the string back, then that's fine, but we don't have to await any response here. Just as I mentioned earlier, it's unidirectional. You just make the call and it should basically suffice for what we are trying to achieve. And this is the Feign client that we have registered for the webhook, and we then make the call in our business logic event handler service over here, and we make the call right here. Then based on the response, we just return it true, and we basically continue with our processing. But also, as I mentioned, we don't even need to wait for this. we can essentially do that and then just say return true over there. And if there's because this is now in a try catch, we can basically just return a true if this call was made successfully. If it failed for whatever reason and there's some issues that it broke, then we do basically catch the exception and then throw or return a false over there with the log that we can debug the issue and address it at that point. So that's it for the event trigger microservice that calls our webhook. Now we're going to move to the webhook microservice and see how things are done over there. So we already know we are calling the post employee endpoint. So we're going to go to the controller and see how things are done over there. So in the employee controller, we have our REST controller annotation and we have our request mapping annotation, which is /API. This is the routes that we are using to get to the employee controller. And then we have our dependency injection of the employee service where the employee business logic sits. And we will only be doing one method here because we're only calling one, but these other ones are added so that you can see that you can execute more than one, and based on the requirement in a typical realistic environment, you will obviously have more methods or more endpoints to execute and basically process, or more events to cater for and basically execute what you want. So as I mentioned earlier when we had the update event, so in a case of an update event, you would then be calling the put mapping over here from the source system or the event trigger microservice. That update event will then be a put call to the webhook, and then a delete will be maybe, let's say, remove or something like that. Let's say maybe remove, and then that will basically be a delete in that manner. So that's essentially, in a nutshell, this will be doing that. So let's go through the post and see what is done over here. So in the post, we have a post mapping of value employee consumes and produces a application JSON. We have our request body as employee DTO. You saw that in the employee DTO, we basically have first name, last name, email, and phone number. All of these are same as our typical POJOs, and nothing fancy that we're doing over there. Just setting the fields for employee, and that's about it. And then once we get the request coming in, we just log that to create employee event received. And once this event is received, we then return a response of OK with the response from the create employee service. Let's go to the create and see how that guy looks like. So in the employee service, which is where our business logic sits, we have our annotation add service over here, and then we have our create, which returns a string, and you'll see we also log that we received the created employee DTO with first name, and you see that we return a string of created employee with that particular first name. So we're just returning a string. We're not doing anything fancy. There's no business logic really that is within all these methods. So we have a create, we have an update, we have a delete. And this is where, in a realistic world example, you will have your JPA repository or your actual processing will be happening here based on the payload that you received. To say create this employee into the database, or add these particular fields for this particular payload, and then send it to a downstream system or to an upstream system, or whatever the case may be. So that particular flow will basically sit over here to process that data even further and get some fields that you would need to add in there and basically propagate that data to whatever stream you basically wanted to land. And then on the update, you basically be doing the same thing, just updating the data, whether in the database, whether sending it to a queue, whether sending it to a Kafka topic, sending it to a different microservice, and things like that. And then on the delete, you will be basically following the same journey and the similar logic just in this case, we'll be removing or adding some fields to say flag this particular payload as a remove attribute, and then go to remove in the database, or go or push that into a queue with a field that says flag this for removal and things like that. And basically, you will basically be processing that accordingly. And that's about it for the employee service. So going back to the um, employee controller, let's go back there. So now that we know we've got our payload and we've processed our payload, we then just return the response, which is a string. And then based on that response, then event trigger is able to know that everything is, it ran through fine. But because we don't really need a response to come back, we can essentially just do a void over here, and we can just remove all of these, and all of that. And this should suffice for what we're trying to do, because we don't really need to await for any response. We already send the data to the webhook, and the webhook will then process that data. And if there's any status update that needs to happen, it will happen within this microservice, or an upstream or a downstream system, where it will then be propagated to a queue or to a topic. And then whatever listener is a consumer of the queue or the topic will then get the latest status of that particular payload to, excuse me, to say the data was or the event was processed successfully, or the event failed, or the event is due for a retry, and things like that. So based on whatever status that you have, and you can basically set the correct status and the correct communication based on the response or the result of the at the end of that particular event processor. So in the same way over here with the other two, you can basically just set these as a void, and it will basically suffice for what we are trying to achieve. And in a nutshell, we are pretty much done with our employee or our employee controller and our webhook microservice. And I hope this was helpful to help you design your webhook microservice implementation within Spring Boot. And if you have any questions, you want me to add maybe, let's say, database into this particular example, so that you can interact with some real events, some real payload, and you see how we can basically create the entire flow or create the entire journey of adding an employee, updating, and removing that particular employee. But this is just an example of how things can work in a microservice architecture using webhooks. And I hope this was helpful to you. And until next time, for now, cheers.